All right, I'm back. We're on page 290, and we are going to find some derivatives. So we're going to find the slopes of curves at specific points, the instantaneous rate of change of the curve at a specific point. That's what we're doing. We're also going to be using the limit definitions. So I hope you took seriously when I said you need to memorize them because we're about to use them. So if you didn't memorize them, you can look back. You could just follow along. But you need to have these memorized because otherwise there's just no chance you're doing these problems. So I want to find f prime of 2. It says to use one of the definitions of derivative at a point. So the next problem says to use the other one, so it doesn't matter which one we go with. So I'm going to use the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. Okay, so f of x, so it'll be the limit as x approaches 2 of f of x, which is negative 16x squared plus 5, minus f of 2. So f of 2 is 2 squared is 4 times negative 16 is negative 64 plus 5 is negative 59. And then that'll be over x minus 2. Okay, so far so good. Limit as x approaches 2. So you just algebraically simplify. So it'll be negative 16x squared. So I have plus 5 and I have minus 59. So that's plus 59. So it's plus 64 over x minus 2. So far so good. Maybe. I don't know. How much space do I have? I have a lot of space. Okay. I see some factoring that I can do. So I should point out, and I should have been pointing this out like a million times, the limit definition of the derivative always gives you 0 over 0. Like starting off, you know you're getting 0 over 0. You get 0 over 0 every time. Like first row here, definitely 0 over 0. This one, still 0 over 0. It's all about like, will it stay 0? It's going to be 0 over 0 basically until we get rid of that x minus 2 in the denominator. So you know that, but you don't usually write it because it's like such a common thing. So now what I'm going to do is I'm going to factor negative 16 out, and I get x squared minus 4. This is looking good because x squared minus 4, so that would be 0 over 0, equals limit as x approaches 2, so many steps, negative 16, got x plus 2, x minus 2, there you go. Okay, so it's still 0 over 0, but in the next step, we're going to cancel. So I should have been emphasizing the 0 over 0 thing a lot more. But you know, without anyone there to ask you questions, it's like hard to know what to do. All right, if I sub in, I will get negative 16 times 4, negative 64. So I'm going to say f prime of 2 is negative 64. Okay, so that's the slope of the curve at x equals 2. So it's very steeply decreasing. If you moved over 1 step, you'd have to move down 64 steps. That's insane. All right, so that's one definition, but now I'm supposed to use the other one. So this one will be the limit as h approaches 0. So f prime of 2 is going to be the limit as h approaches 0 of f of 2 plus h minus f of 2. My inclination, it's like I just want to skip a million steps, but I know you're with me, so I'm not going to do that. The limit as h approaches 0. All right, f of 2 plus h. So this one's a little more annoying in general, I would say. We get this minus f of 2 is still negative 59. And then all over h, okay, equals, whew, do I expand? I think I have, I'm going to go for it. Limit as h approaches 0 of negative 16, 4 plus 4h plus h squared. And then plus 64 again, all over h. We're going to go one more step, but you know that on the next step, if everything that doesn't have an h doesn't cancel out, then you have messed up. Go back, fix it. Here, limit as h approaches 0 of negative 64 minus 64h minus 16h squared plus 64. Everything in that row that doesn't have an h is going to cancel out. So at the very least, we're not definitely wrong. If it didn't cancel out, we would definitely be wrong. Limit as h approaches 0. So the 64 and negative 64 are gone. What I'm going to do is I'm going to divide by h and get negative. So I'll do quantity negative 64 minus 16h. And then if h is 0, I get negative 64. So I found again, whoa, where are you going? That f prime of 2 is negative 64. You will always get the same answer doing it both ways. So if you think back to that assignment from the previous notes, you got the same answer from difference quotient 1 and difference quotient 2 every time. Those were all derivatives. You already found the derivatives of 6 functions at 6 values that you made up because we were doing the same thing. All right, I'm going to keep going, I think. Just knock out this page, I guess. All right, using whatever method you think is easier. I think that the method where x approaches a is easier because it's faster. It's less common, but I'm going to use it anyway. So g prime of 1 can be the limit as x approaches 1 of g of x minus g of 1 over x minus 1. I always like to start out writing the notation. So this is the limit as x approaches 1 of g of x, which is radical 3x plus 1, minus g of 1 is the square root of 4, which is 2, over x minus 1. Now what do I do, right? I look at this and I say, this is the type of, this is what we've been preparing for our entire limit lives. We're going to rationalize the numerator. So multiply by radical 3x plus 1 plus 2 over radical 3x plus 1 plus 2. Okay, so you simplify the thing that you're rationalizing, you leave the other one alone. So we're not going to expand the denominator because that would be a horrible waste of time. Limit as x approaches 1. So you're going to get the quantity 3x plus 1 minus 4 over quantity x minus 1, quantity radical 3x plus 1 plus 2. Sometimes I start chuckling because it's just like so much writing. And especially like when you know where it's going, it's kind of like, can I stop at some point? Like, you can stop when you're done. I'm not going to rest till we're done. So this is 3x minus 3. I'm just going to make it, I'm going to skip a step. 3 and then x minus 1 over x minus 1 radical 3x plus 1 plus 2. Okay. Now we can cancel out that x minus 1 and the 0 over 0 is gone and we will get a result. So I'm excited about that. Limit as x approaches 1 of 3 over radical 3x plus 1 plus 2 equals, if I plug in 1, I get square root of 4, which is 2. I get 3 over 4. So don't lose sight of what's happening, right? What we just found, this is, why can I not zoom? Okay, so we found that g prime of 1 is 3/4. That's the slope of the curve at x equals 1. So if I graph this thing, so I'm graphing g of x. So the domain is greater than or equal to negative 1/3. This. At x equals 1, if I drew the tangent line, the slope is going to be 3/4. It's also the slope of the curve. Slope of the tangent line, slope of the curve, same thing. All right, so let's do, I invaded the space of this problem. I don't know how much space I'm going to need. Can I move this using some iPad magic here? Let's get you over here. I probably should have moved everything. Let me do that. Bear with me for 1 second as I move everything. Okay, look at that. When you don't space it out correctly, just reinvent it. All right, I'm going to use the same method because it's more efficient when you're doing them this way. I should say, you don't like do a million problems like this. You just do enough until it's in your head and you can never forget it. How many is that going to take? However many it takes for you. Here we have an interesting scenario where m is the variable. That's fine. So I'm going to do h prime of 2 is going to be the limit as m approaches 2 of h of m minus h of 2 over m, oh my god, m minus 2. Okay, let's do it. Limit as m approaches 2, 3 over m plus 1 minus, if I plug in 2, I just get 1, minus 1 over m minus 2. All right, so what am I going to do here? I'm going to first just simplify the numerator. So I'm going to just deal with that. So it's going to be common denominator, the limit as m approaches 2 of 3 minus the quantity m plus 1 over m plus 1. That's not a 1. M plus 1 all over m minus 2. So that's good. Is it good? I don't know. I mean, it's not terrible. Equals the limit as m approaches 2 of, all right, what do I get? 3 minus m minus 1. So it's 2 minus m overall. Okay, I see where this is going. So 2 minus m over m plus 1 all over m minus 2. Let me simplify that again. The limit, so really your algebraic skills, like they got to be on point, and if they are, you're gonna be okay. If they're not, you want to work on that. So 2 minus m over, make it m plus 1 times m minus 2. This is that property that we ran into. 2 minus m divided by m minus 2 is just negative 1. So this will be the limit as m approaches 2 of negative 1 over m plus 1, which is negative 1/3. Therefore, h prime of, I don't even know what we're doing, h prime of 2 equals negative 1/3. That is the slope of this curve at m, because that's the independent variable, m is equal to 2. So we did it. We did 4 different derivatives. Well, 2. We did one of them 2 different ways. Slope of the curve, negative 64, no matter how you do it. Then we did both of these using what I believe to be the more expedient method, not necessarily the most common method, but it is the most expedient. So I'm going to cut this video up here, and I will see you in the next one where we will continue to learn more and more calculus. And this is the beginning of a really long road, but it's a fun road, and I hope you are kind of enjoying it. So I will see you then.